Question 2 from tutorial. Here is our differential equation. Squared times dy dx plus 2x times y equals to cosine squared x. We begin our procedure. We need to rewrite, but it turns out we don't need to. Why is this the case? If you look at the introduction, we have to re-express, but we begin by checking if f2 equals to f1 prime of x. It turns out, in this case, it is already so. f1 is x squared, f2 is 2x. If you differentiate f1 x squared, you get 2x. So indeed, f2 equals f1 prime. So we don't need to do anything. The equation is in the form that we want. Therefore, it becomes d of dx of x squared times y. The left hand side becomes this. The right hand side, same. Next step is to integrate the left hand side, allow to release x squared times y. We integrate the right, it gives us cosine squared x. We have to integrate that, but it turns out we can use a trigonometric identity to convert cosine squared x into half times 1 plus cosine of 2x. We know how to integrate this. It gives me half times x plus 1/4 times sine of 2x. At this stage, we introduce our arbitrary constant c. So we have this equation. We solve for y. To do that, we need to assume that x is not equal to 0. Because when we do that, we can divide throughout our expression by x squared. This gives us y equals to 1 over 2x. We divide x over 2 by x squared. Similarly, plus sine of 2x divided by 4x squared plus c divided by x squared. This gives us the set of solutions where c is an arbitrary constant. We don't have any special conditions because our differential equation was already in the correct form. We don't need to impose any new conditions. All we must assume for our solution to make sense is that x should never be 0. If it were 0, then you see this expression would mean dividing by 0, and that does not make sense at all. Always have the condition that x is never equal to 0. In fact, you can also check it never makes sense in our original differential equation. If you were to set x equals to 0, this would be 0, this would also be 0, so the left hand side is 0, but on the right you would have cosine of 0 that equals to 1. 1 squared is 1. It would mean saying 0 equals to 1. That it doesn't make sense at all. It's not allowed. Therefore, we never can have x equals to 0. X is always non-zero. This is the solution, and this solves question 2.